Hello and welcome. Let me read this problem. Students are playing with a football on top of a cliff of height 47 meters. They notice that their physics teacher, 2 meters tall, is walking on the ground towards the base of the cliff at speed 5 meters per second. They kick the ball horizontally when the teacher is 111 meters away. With what the speed the ball should be kicked so that it lands on the teacher's head? It's a funny problem. It seems students are very angry with the teacher. God knows for what reason. Maybe he's a bad teacher or he has given many assignments to students. Whatever it is, it's a funny situation. But so how it is, I mean, there's a cliff. And the cliff is 47 meters high. Suppose this is a cliff, this is a 47 meter high. Students are playing football here, and from the cliff, from the edge of the cliff, the teacher is 111 meters away. And the students are giving a kick, that means giving a horizontal velocity to the ball. And they have to decide with what velocity they should kick the ball. That means the ball should fly in horizontal direction at what velocity, such that the teacher who is walking towards the base, and the teacher is walking at the speed of 5 meters per second towards the base, the ball is kicked when the teacher is at 111 meters from the cliff, and the velocity should be such that the ball lands on teacher's head. Okay, so that's the situation. So what is that velocity with which the ball should be kicked? That's the question. So let me make a sketch. I need to clear some space because it's a long problem. Okay, so okay, so let's say this is the cliff, this is the ground, the ball is to be kicked from here. And let's say the teacher is here. This is the teacher. And we are told that the teacher is 2 meters tall, right? So this is height 2 meters, teacher. So the ball is kicked. This height is 47 meters. The ball is kicked horizontally. So we want to find out this velocity with which the ball is leaving the cliff, and this distance of the teacher is 111 meters from the cliff. The teacher is walking towards the cliff at a velocity of 5 meters per second. The ball is kicked. Maybe let's say that the teacher is somewhere here, right? And the ball is, so this is, the ball is landing on the teacher's head, right? That is the situation. So we are asked to find out what is the velocity. Now see, this problem can be, we can immediately see few things. This is a projectile, and let's say that when the ball is kicked, it takes time t to reach this position, right? To land on teacher's head. So it's going to take time t. During that time, so when you hit the ball is traveling horizontally and is coming down. That's how projectile works. And the teacher is walking towards the base with 5 meters per second. So in time t, the teacher comes over here, and in time t, the ball lands on the teacher's head, right? So the distance traveled by the teacher to reach here, where the ball is going to hit his head, is there is some distance. So that distance will be traveled by the teacher in the same time t. So the distance traveled here up to this horizontal distance from here, that means from this teacher. So this is 5 is the velocity with which the teacher is walking, t is the time, so 5t. Now see, if the ball is moving horizontally, So how much distance the ball will travel in horizontal direction? That will be, when that's the horizontal displacement of the ball, or the distance traveled by the ball. It is V into T, because that V is unknown, but so V and T both are unknown. So let's say that distance, this horizontal distance, we can say is V into T. Okay, so you can see V into T plus 5T, right? Vt plus 5T is 111, because 111 meters is the distance distance from which from the cliff where the teacher is standing. That is the distance, and then he starts moving, right? So this is 111. So we have an equation, 111 is equal to Vt plus 5T. Now if you know T, right, it's possible to find out V, because we have an equation, there are two unknowns V and T. If we know T, we can find the value of V. Now how would you find out the value of T? Now see, again we'll come back to the projectile motion. We know that in projectile motion we have the vertical displacement and horizontal displacement. They can be completely separated. We can separately apply kinematic equations for each of them. Let's consider vertical travel or vertical displacement of the ball. The ball is going to travel down. Now the height of the cliff is 47 meters. Is the ball going to get displaced downward by 47 meters? No. Why? Because the ball is going to hit on the teacher's head. That means the teacher has height of 2 meters, right? So the vertical displacement of the ball is 47 minus 2, which is 45. So downward vertical displacement of the ball is 45. So consider the ball as if the ball is moving down. The initial vertical velocity of the ball, you can immediately say it is 0, because it is hit horizontally. It has 0 vertical velocity. Initial vertical velocity is 0. It will of course pick up the velocity as it comes down, right? Because it's being pulled by gravitational acceleration. So initial vertical velocity of the ball is 0. It is going to be displaced by 47 minus 2, it is 45, right? So but let's consider the vertical displacement only, because we can separate vertical movement from horizontal movement and write down the kinematic equation. S is equal to ut plus half at square, right? S is ut plus half at square. Now what is S? S is the vertical displacement. We know that displacement is 45, 47 minus 2. So this is 45. Time is T. This is at same time, the time which the ball takes to come down, get displaced by 45 meters is the same time for when the ball is horizontally displaced, right? This ball is coming down, moving horizontally. So this is the same time. During the same time, the ball moves from here to here. The ball moves from this level to this level. Okay. So, and during the same time, the teacher comes from here to here, right? So we want to find out that time, and we can find out with this equation. This u is initial vertical velocity of the ball. Now we are considering as if the ball is just moving down. So it's a rectilinear motion. So initial vertical velocity of ball is 0. So it is 0 into t. A is acceleration, right? So now see, we can choose acceleration. Acceleration is 10 meters per second square. We can give the sign as negative if you want, because acceleration is downward, but the displacement is also downward. So if you put A as minus 10, you need to put 45 as minus 45. So it doesn't matter, sign is going to be cancelled anyway, right? So you can consider downward as positive, it doesn't matter. If downward is positive, the displacement downward is positive 45, acceleration downward is positive. So it is half into 10 t square. So what do you get here? This will be essentially 5t square. So I can take it on left hand side. So 5t square is equal to 45, which means t square is 9, which means t is equal to 3 seconds, right? So now we have got t as 3 seconds. Once we have t as 3 seconds, we come to this equation, and that equation which we had written, we had stated was this: v into t, which we have found as See, v into t plus 5t, right, is equal to 111. Now t is 3. So I'll substitute t as 3. So I'll write it as 3v plus 15, right? 5 into t is 315 is equal to 111. This is 111. So which means 3v is equal to 111 minus 15, and you can see this is 96, right? So 3v is 96, which gives v is equal to 96 by 3, and that will be 32 meters per second. So the ball should be kicked horizontally with a velocity of 32 meters per second. Thank you.